Do Matrices Part 2 by Julia Vargas. The formula is found by subtracting the products of the diagonals, which is on the screen right over here. Or in other words, you multiply top left to bottom right diagonal, then you subtract the product of the bottom left to the top right, just like over here. And here is the origins of determinant. And first, an easy one, you do 3 times 2 first, and then 1 times 4, and that is 4 minus 6 equals minus 2. And then the medium problem is this, and you would multiply 1 times 3 diagonally, 2 0 times negative 4, and you subtract all of them, which gets you 3. And then a harder problem, I added decimals, and you would multiply 5.4 times negative 6.7 and 7.4 times 8.3. And you subtract both of the equations, and you get negative 67.42. And then inverse of a 2 by 2 matrix. Formula: swap the positions of A and D, put negatives in front of the B and C, and divide everything by the determinant, which would the equation be AD minus BC. And here's a little chart demonstrating that, and the way you can check it is because 8 times 1/8 equals 1, so that goes from there. And then here's an easy problem. You do 4 times 6 minus 7 times 2, and that's all under 1, and you get this, and you multiply it by 1/10, which gets you the decimals, and there's the answer. And then a harder problem would be a longer one, which is 9 times 2, and you would have to write it matrixly, sorry. And you multiply out all the numbers, and then multiply by 1/2, and then R2 to equal R2, and you get the 1/2. Then you would go from this to over here, and it's R1 plus 6R2 over R1, which will get you this, 1 over 9 for this, and that, which gets you the answer. And then here we have to check if the matrix is invertible. In an easy problem, I've underlined the numbers that you will multiply: 3 and 11, and 2 and 7, and you subtract just like you would do with the first problem, and then 33 minus 14 equals 19. So yes, the thing is, so it is invertible. And then a hard problem would be 5 and 6, and you subtract them. You got you 30 minus 30, which is 0, which means that it's not invertible because it equals 0. And then transforming a polygon using matrices. We can find the image of a transformation using the following steps. Find the coordinates of the vertices and arrange them as a matrix with the x value in the top row and the y value in the bottom row. Multiply the coordinate matrix by transforming matrix. The results matrix will give you the coordinates of the new articles, also with the x value in the top row and the y value in the bottom row. And then you just plot the results. In an easy problem, I did a triangle with the coordinates of 0, 0, 0, 1, and 1, 0. So you have to write down the coordinates in order to multiply it to this number that they give you the problem. And here I am multiplying all the numbers together, and you would multiply, which would get you to this, but you're not done yet. You also have to graph them. And here I am showing you, and here are the new coordinates as written as x and the y. And that is it. And then the hard problem, it's not a triangle this time, it's this shape. Yeah. And then you would have to write down the plots, which is this. And then you would have to multiply it to the 0, 3. And then here we go, we multiply all of them together, which gets you this, and again this is the x value and this is the y value, so then you write them down, -6, 3, and continually, and you graph it to this. And here are the coordinates, and here's my works cited at the end. Thank you for watching. Woo.